Good day to everyone and welcome. My name is Clark Morrison. I'm the State Pavement Design Engineer for North Carolina Department of Transportation, and I'm also the chair of the AASHTO Pavement ME Design Task Force. Welcome to the fourth webinar in our fiscal year 2023 series. Today's topic will be PMED web application updates. Your presenter today will be Chadwick Becker with ARA. The PMED Task Force provides guidance and oversight for the maintenance, enhancement, and of the Pavement ME Design software. Ryan Fragapane is our AASHTO Project Manager. Ben Sade is the AASHTO Assistant Project Manager. Again, I'm the chair of the task force. Hari Nair of Virginia DOT is the vice chair. Our other members are Patrick Birrell with Ohio DOT, Kumar Dave with Indiana DOT, Dulce Feldman with California DOT, and Ian Risch with the Georgia DOT. Suzanne Chan is our liaison to the Canadian organization. She's with the Ontario Ministry of Transportation, and Tom Yu is our FHWA liaison. And I think I'll turn it over to you here, Chad.
Yes, thanks very much, Clark. Okay, so with that, we'll dive right in. We'll start with our first two poll questions. I'm going to open up the poll now. We'll have 1 minute to answer. So you should see the poll questions now. Thank you very much. All right, so we'll move on now to the main part of the webinar. So thanks again, everyone, for attending. And thanks again, Clark, for the introduction. We've got a lot of exciting things to cover today, all the work that we've done in FY23. We're going to also take a look at some of the enhancements that we have planned for FY24, sneak peek at the BCT web application as well. So we'll get started here. The goal of the webinar today is to review all the enhancements that we implemented in FY23 and to understand how those enhancements impact the usability of the application, as well as the impact on the system outputs. So in FY23, we will have had 14 releases of the web application. That's basically version 3.0 through version 3.14. We're currently on version 3.12. We anticipate 2 more releases by the end of the fiscal year this month. And just a note that none of the releases that we've had thus far have associated calibration update requirements. So these are all new features, user experience improvements, no calibration changing requirements. So this slide is supposed to show our release cadence. So we work closely with the technical review team, the TRT. We meet with them twice a month, and we go over the features that we've implemented for that, the requirements that we've implemented for that sprint, that 2-week period, and then we get feedback directly from the TRT, who are representative of the users. That really helps us get the features just right, helps us understand the challenges that users have when they're working in the system, and to mitigate issues and make the workflow smoother. So that's been a really big help. So I just want to take a brief minute to thank the technical review team. I've got them listed here. They've been awesome, and it's been great having everybody help us out as we go through the development process. If you are interested in serving on the technical review team, you can go ahead and send me an email. We have a couple of slots open, and then there's a vetting process that I'll submit to Ryan Fragapane, the project manager, for folks that want to be on the TRT. Okay, so that's the FY23 release cadence. Next, we're going to talk about the multiple asphalt overlays in the web application. So we've completed the work on this. It's going to be available in the web app at the end of this month. Right now, it's just in testing. So basically, users are going to be able to select from a list of design strategies that reflect multiple overlay approaches. So the objective of the feature is to allow users to select those multiple asphalt overlay design strategies for a second or third asphalt overlay of an existing pavement such that a consistent design approach is being provided in the system. And so to implement that feature, we had to perform a couple of key steps. We had to prepare this decision tree flowchart on the simulation of all the rigid and flexible pavement layers when designing a new asphalt overlay of a pavement that already has an asphalt overlay. And then we needed to revise the PMED software in accordance with the decision tree flowcharts, and then make revisions to the user interface in terms of construction and placement dates for the new pavement, the existing asphalt overlay, and the new asphalt overlay. So by the end of the month, the team is going to have selected some LTVP sites with multiple asphalt overlays to help verify and confirm that the methodology that we're using for predicting distresses for these types of design strategies are correct over a range of conditions. And then lastly, we're going to put together a report document on the process, what our recommendations were, what the implementation was, and then we're going to provide all that to Comp 5D for review. So that's these slides here. So that's preparing the decision tree. This is making the revisions in the software, using some of the existing LTVP sites to help confirm the methodology, and then preparing the report. So let's take a quick look at this in the application. So I have the two designs loaded up here. One is an AC-AC-AC, and one is an AC over AC-JPCP. So we'll take a look at this. Just right away, some changes that we see in the UI. There's a new design type selection, multiple overlays / rehabilitations. You can select that, and that'll give you access to the multiple overlay pavement type selections. So here you can see we have AC overlays of AC over AC, AC over JPCP, CRCP, semi-rigid, and JPCP fractured. And one of the main results of selecting this particular design strategy is that your structure default and sort of management is going to change. So now we have the proposed overlay, which is this one on top. We have the existing overlay, which is the second flexible layer. And then we have the original structure, which is the third flexible layer in this particular case, along with the non-stabilized base and subgrades. So this is an example of what the AC over AC overlay looks like. Wanted to also just give you a quick peek at the AC over JPCP. So it's exactly the same thing. We've just selected AC over JPCP, and here's the structure for that. So within the layer selection editor, you can actually come in here. You can move around where the existing overlay is. You can move around the original structure. The program's going to check that to make sure that it's still a valid design strategy structure in the system. But this is all drag and drop compatible to make that easy to work with the different layers. So the outputs, there were some changes in the outputs. Let me bring up, not the values, I should say, but just the report. Let me bring up the AC example. So this is the same project. Excuse me, same project. I just had it pre-run basically. We can see all the different distress types still being calculated, all the charts. Basically everything has remained the same. Within the output report, we now just have the extra layer identified in the output. Okay. So we are going to hold a webinar on multiple asphalt overlays early in FY24. It'll probably be combined with the work that we've done on creep compliance, which we're going to talk about in just a little bit. All right, so creep compliance. So this is using input level 1 dynamic modulus to compute level 2 creep compliance. We just finished the integration. It's going to be available soon in version 3, definitely be available by the end of the month. The objective of this feature was to develop a standard procedure to transform the level 1 frequency-based measured dynamic modulus master curve to a level 2 time-based creep compliance master curve. The new procedure is going to replace the current procedure, which is based on the AASHTO test 322. The new level 2 creep compliance procedure allows agencies to estimate all of the asphalt properties needed to predict transverse cracks. So the benefit here is that it reduces the testing requirements and therefore the costs normally associated with level 1 creep compliance testing. So we'll give a separate webinar on this topic. We'll probably tie both this and multiple asphalt overlays together, just because the multiple asphalt overlays by itself wouldn't be long enough for one webinar. So in that webinar, we'll go over the procedure and how the changes were developed and implemented, and that'll be in early FY24. I'd also like to extend a special thanks to Chuck Schwartz. He is reviewing the work that we've done on this particular task. Okay, so next in the completed features list are the UI UX improvements. So there are a whole bunch of these. They're listed here. We're just going to step through them once at a time and take a look at it, some screenshots. So we have dynamic modulus and master creep compliance master curves. You can actually generate these now within the application. So once the design is ready to be run through the analysis, you can actually just run the dynamic modulus, take a look at the resulting master curve, the fitting parameters, the shift curve, the viscosity curve. All of those are available right there in the UI without having to run the full analysis. And that's to help the users, ensure that their dynamic modulus data is valid. Same thing with creep compliance. You can generate that master curve as well, and also view the associated inputs. So previously in the application, you could not modify the IRI standard deviation equation. We discussed that, and the decision was made to make this an editable equation, so you can now get in there and modify the IRI model standard deviation. We also spent some time working on a set of traffic charts. Again, these are charts that you can view without having to run the entire analysis. So you can take a look at things like the cumulative flexible easels, the cumulative heavy trucks chart, total truck by growth, total truck growth by class, and total trucks by class. These are all now available in the user interface, and you can hover over the chart lines to actually see the data. One of the big features that we added is a library previewer. Previously, when you were working with library data, say for materials or traffic, you kind of had to cleverly name your library so you could remember which library it was. So we wanted to improve that, make it easier to work with. And so now you can, when you're going to import data into one of your designs from a library, when you select that library, you can actually look at the data. It has a description, and then you're asked to confirm the import to make sure that is correct. There's one caveat to the previewer. It does look like you can change the data here. That won't actually change the data in the library. You have to go to the actual library to make those changes. Okay, we also fully integrated the help manual and the manual of practice in FY23. Those were converted over to technology called Bookdown. This lets us eliminate all of the repetition that we saw in the previous manual in the previous help manual. And it makes it a lot easier for us to extend and modify the help manual as new features are added to the system. And then having the connection points hooked up for the manual practice, that was partially working in the desktop application that's now fully implemented in the web application. So every property that has a relevant link to manual practice is set up, and we'll link directly to it in the web application. And then one small feature that we added, again, just providing some more information to users when they're working with workspaces. We added a description field to the workspace that lets you provide a description so you know what the purpose of the workspace is. We also added the design name, design type, and pavement type to the header inside of the design editor component. So that way you, no matter which part of the component you're on, you always know which design you're working with. And we also added the design name to the tab, which is the second screenshot here below. That way, if you're working, with 2 or more designs, if you're doing some comparisons, and have them open in separate tabs, the names of each design will appear on the tab. Just makes it easier to keep track of which design is which. All right, one of the major work activities that we had in FY2023 was the BCT web application. So our task was to transition the BCT web app, the BCT desktop application into a web application. And as part of this process, we recognize we have these different tools that are all a part of the Pavement ME Design tool suite. So we have MapME, which allows you to visually create projects for Pavement ME Design by selecting them off of a map. It pulls in data from NHPN for the National Highway Planning Network for traffic. It also uses the Surgo data set for kind of some, call it level 4 or so soil data. It's supposed to give you a general idea of what that design is going to look like. And that allows you to export a DGPX file that you can then manually import into Pavement ME Design. And there'll kind of be a theme for that here that we're going to address in the near future to sort of bring all of these tools into the Pavement ME Design tool suite and make transferring data between them a seamless operation. There's also the CAT. That's going to continue to be updated as we release new versions of the application of Pavement ME Design. Multiple asphalt overlays will need to still be added to the CAT. And then as we integrate NCHRP projects into new research into the tool, the CAT also needs to be updated. That calculation tool that we're going to talk about here in just a second, that we want kind of a seamless switching between these different products. That calculation tool can also generate a DGPX file, which you can then import into Pavement ME Design. And we want to, again, automate that process so it's just a button click rather than having to download and then. And then there's also the repave scoping tool. So just as a reminder to folks, the Pavement ME Design back calculation tool is a deflection data analysis and back calculation tool. It's a standalone software program, the desktop application, that can be used to generate elastic layer modulus and layer thickness inputs for Pavement ME Design for rehabilitation designs. So these are the major features of the system, and we're going to go over these major features, and then we're going to go over several screenshots that show the new web application and kind of demo these features. So the first one is analysis of raw deflection data files obtained from falling weight deflectometer testing devices. So this includes QOP, Dynatest, and JILs, and there are several file formats. We're going to look at each one of those here in just a minute. So we automatically parse and import those into the tool for you. You can perform back calculation of in-place elastic layer moduli for flexible and rigid pavements using the EverCalc analysis engine. We went with EverCalc because the folks that developed EverCalc gave us permission to use their engine directly in the system. Direct integration with PMED inputs, rehabilitation designs. We're going to take a look at that in just a minute. It performs loss of support analysis and load transfer efficiency calculations. And it has integrated support for GPR thickness data. The design segmentation within the back calculation tool is based on the cumulative area difference method as described in the 1993 AASHTO design guide. So we'll take a look at some of the screenshots here and hopefully answer some questions that folks have about the BCT. So when you load up the BCT, the first thing you'll notice is we've rebranded it to look the same as the Pavement ME Design web application. And when you first log into the PMED suite, you'll be able to select whether you want to navigate, whether or not you want to sign into the BCT or you want to access Pavement ME Design. And we're going to be bringing in the other tools into this sort of seamless integration format. So once you've signed in, you can be either defaulted to the BCT, you can default the application to Pavement ME Design, you go to the one that you default to. In this case, let's say it's the BCT. So there are two different ways to get the FWD data into the program. You can pull it in from an FWD file type. That's going to include the standard types, which I think I have that in another slide. Or if you have a legacy desktop BCT project, you can also load that into the web application. Yeah, so here are the different FWD file types that we accept. So the JILs.dat, QAB FWD, Dynatest, a couple different versions of Dynatest, the FWD F20 and F25 files. We also parse the MDB access files. These are the files that are generated directly by the FWD device. So we read that data in, gets parsed in. You can see we've got plate radius, sensor spacings. You can optionally load a thickness file. You can select whether or not to calculate pavement temperature. You can upload sensor spacings. If you have a file for that, we provide a CSV file format that you can use to fill that in and then upload it. And then also all the different test points down below. That includes your stationing, your lane, test type, air temperature, and so on. So the next step after reading in the inputs is the segmentation sensor view, and this lets you look at all the different sensors, the data from the FWD, and it allows you to filter on that data. At that point, you want to get into the structure definition. So you'll skip segmentation. No, this is segmentation. Yep. So after that, we'll get into the structure definition. There are two. I want to come back to segmentation briefly. There are two types of segmentation. There's automated, which we described previously. Users can also set up their own segmentation. So if you see something that doesn't look right, or you want to adjust the recommended segmentation, the user has complete control over that. The structure definition page allows you to define the different layer types, their thicknesses, modulus values, the mean seed values, and then whether or not you want to do a single segment or multiple segments. And then you have the back calculation screen. So this is just prior to running back calculation. You can set your standard temperature, you can select your sensors, you can select which segment you'd like to view data for, look at the modulus values, layer compensation, and depth to bedrock charts. And once you click the back calculate button, that will run the back calculation and produce the physical features output. So you've got LTE here and void detection charts. Once that's completed, you'll have your average modulus values, standard deviation information, thickness information. The purpose of this screen is to link that information to a specific set of pavement ME design layers. So for this particular segment, we had an AC layer. We want to link that to the default asphalt concrete in pavement ME design. And then we have a granular base called an A27 and a subgrade called an A5. So this just sets up that mapping for each segment. And then you select the analysis type. This will be an AC over AC. Set these other parameters, and then click the Export to ME Design button. That's going to create a DGPX file. At that point, you have the DGPX file. It's saved on your device. You can then switch directly from the BCT app to Pavement ME Design. And then once you're in Pavement ME Design, you can upload that file to your sessions. Let me just pull this up. Go to Designs. Got it ready here, so we'll pull up. Where did I put it? Yeah, we'll pull up the BCT DGPX file that was generated. So this one you can see is named Exported from BCT Legacy F25 FWD_1.dgpx. This is the file that was generated by the BCT application. So we load that straight into Pavement ME Design, and it's basically ready to go. So the data, including NDT modulus, is available directly in the system. Just make a couple adjustments to get to that. This is to level 1, back to structure. These numbers probably won't look correct, but don't worry about that. That's just us putting in some values to run through the demo. So you can see the NDT modulus is already entered for you. That was pulled in from the data that was provided by back calculation tool. Okay. So that's the demo for the BCT web application. Again, the main goal, provide a seamless experience between these different tools. The BCT is the first one we're tackling. CAT's probably going to be next. We want people to be able to switch between the tools quickly and easily. When you purchase a Pavement ME Design subscription, it comes with the BCT, and you should be able to access it easily from within your subscription. So that's sort of the focus there. Just some common questions that we get about the BCT, and I want to make sure I address these. Can you directly export from the BCT web application to Pavement ME Design? The answer is not yet, but soon you'll be able to do that. For now, you have to go through, you just have to export and then import it into Pavement ME Design. Export from the BCT, import it into Pavement ME Design. Does my PMED subscription come with access to the BCT? Yes, it does. So your subscription gives you access to the BCT, the same level of the number of seats that you purchased for Pavement ME Design. So if you've purchased a 9-seat subscription, you have 9 seats to the BCT as well. Sometimes you might need more BCT seats, but not more Pavement ME Design seats. And yeah, the answer is yes, that's fine. You can purchase the BCT seats separately from Pavement ME Design seats. And those will all be covered under your subscription. Okay. So the other major refactoring effort, the other major effort that we went through in FY23 was the Julia refactor. It was quite an undertaking to go through Julia, and the goal of the effort was to refactor Julia for clarity and maintainability purposes, and to attempt to improve the runtime of the algorithm. So right now, Julia is the second slowest part of the flexible analysis runtime, making up a large percentage of the total analysis runtime. So as part of the process, we created a new linear elastic analysis module. We called it ME Design Linear Elastic Analysis, MEDLIA. But that particular module was based mostly, but not entirely, on Huang's description of the Ken-layer LEA programs, mathematics, and equations. The module had all the desired non-functional requirements, and it was eventually made to run as fast as Julia with very nearly identical outputs in the full bond case, but the partial bond and zero bond outputs were very discrepant. So as a result of that, we decided to switch to, we were going to pause MEDLIA's development as the new LEA to use in the system, and to apply the techniques and experiences that we learned in the creation of MEDLIA back onto the Julia module's code base. And the goal of the pivot was to achieve all or nearly all of the non-functional requirements, performance and maintainability and so on, while keeping Julia's output stable and hopefully producing some modest performance improvements. An important artifact of the Julia refactoring, really there's two. There's the refactored Julia itself, which is able to actually be read now and understood by a developer. And probably the most important artifact is going to be a new document that describes the mathematics within Julia, the equations within Julia, in a format that's similar to Appendix B of Huang's textbook, which describes the math and equations of Ken-layer. And we're going to make that report available to AASHTO. So that is wrapping up the end of this month. We do anticipate an improvement in the runtime for Julia. Not quite sure what that will be just yet. But you'll recall last year we had a 40% improvement in the runtime, so we anticipate improved performance. But the real gain from this is the maintainability of the Julia code base and the document that describes in detail the science and engineering behind the algorithm. Okay, so let's take a look forward at the FY24 planned enhancements. So we're going to be tackling features and work items from three primary work areas. One is technical debt, the other is UI UX improvements, and the other is engineering enhancements. So one of the primary focuses of the AASHTO Pavement Design Task Force is to ensure that the priority items from these groups are selected each year for completion. And so in FY24, we're looking at the following items from each category. So under addressing technical debt, I kind of want to spend a minute here to talk about what technical debt is. So the PMED code base has really come a long way since its original inception as a research tool 12 years ago. A lot of the idioms from the research tool have caused significant impacts on the speed with which new engineering enhancements can be added to the system. So referring to this type of code that exists in the system as technical debt. And so oftentimes technical debt is a trade-off. So decisions are made which impact future work based on current needs. So addressing technical debt is a major step toward keeping the Pavement ME design software stable and ensuring that future enhancements are easier to add and maintain. And so if we pay down technical debt now, it becomes much simpler to add new features in the future, which means we can add more new features in the future. And this is particularly important when it comes to integrating new research, say from NCHRP. So the first step that we took in addressing technical debt in Pavement ME design was to bring the legacy code base into a single language. It was scattered across C#, C++, and Fortran. So we transliterated the C++ and Fortran components of the system to C#. In the next step, we identified all of the analysis modules in the system and their corresponding dependencies. So the current effort, this refactoring effort of Julia, the refactoring for EICM, and what will eventually be the refactoring of all the other analytical models in the system, involves going through translating each module, creating this document for each module that describes the science and engineering behind the algorithm, and ensuring that the outputs remain the same as we go through that process of updating the legacy code to modern software engineering standards. So we accomplished the first of those translations in FY23 with the updated Julia module, and we're going to tackle the EICM next. The outcome of this is going to be the refactored code and the report, and we'll make that report available to AASHTO as well. And then coinciding with that effort, we're going to tackle a major UI component refactor in the web application. So this sort of dovetails with what I was talking about earlier with the CAT, the BCT, Repave, MapME. All of those right now are these separate sort of tools. They have their own UIs, they have their own controls. We want to unify all of that into one system so that way we can reuse common components throughout the system. And what the user gets from that is a more seamless integration between all of those payment design tools. So we'll create a common layout, a uniform set of components that get used throughout the entire system. So we're also going to enhance the system with some new features in FY24. These include adding a new chart in the UI, similar to what we did with the dynamic modulus chart, the creep compliance master curve charts. And this will show the damaged dynamic modulus chart in the UI. And then we're also going to allow the export of design components directly to libraries, so you don't have to go create a library and then have the design open in a separate window to input the data. You can just hit a button and it'll go through a new library creation process based off of the component that you're in, sort of contextually aware. Engineering enhancements, we're going to implement a new feature for MSCR asphalt designations for determining the level 3 defaults, and we will create and publish a detailed update to the local calibration guide. That's everything that we have accomplished in FY23. Looking forward at a lot of the material that we're going to be working on in FY24. So I want to finish up with some announcements. The first announcement is the Pavement IMI Design User Group meeting. This is the first user group meeting that's going to be hosted by AASHTO. We titled it Moving Forward with AASHTO Pavement IMI Design, Implementation and Training Strategies, September 5th and 6th in Madison, Wisconsin. I've got a link here in the webinar that'll be posted on the IMI Design website. You can use that link to register for the user group meeting. I think it's going to be a lot of fun, very interesting. We've set aside specific time for Harold and Voter to meet with you all potentially individually to answer questions that you might have. That makes me excited. We also have some really great training sessions planned with some design challenges. We get to work with your colleagues on designs, and hopefully we can answer tough and important questions that you have. So look forward to seeing you all at the user group meeting. FY24 potential webinars, we talked about multiple asphalt overlays and input level 2 creep compliance for dynamic modulus, thin concrete overlays, bonded and unbonded overlays, and then we'll do an additional webinar on the BCT web application as it'll be, fully completed. Okay, so with that, I'm going to switch over to second poll question, just one question. I'll open that up now. The question is simply, have you used the new PMED web application at your agency, yes or no? All right, thank you everybody for your responses. Looks like we had a good number of people have actually used the web application already. That is really great. So we will move forward here to question and answer session. So I see that the Q&A is exploded with questions. I'm going to go through those now. So I'll read the question off, and then after we'll get the answer out. We have plenty of time, so if folks have questions, I think we have Shri, we have Voter. If I'm not mistaken, Harold is on, although we're having trouble making him a panelist. So Harold is here as well to ask any questions you might have about the web application or the BCT web app. So we'll go ahead and get started. Will you be including BOCA in these scenarios? I'm not sure what BOCA means. I am guessing that's a typo, and Jay, you meant BCOA?
That's my guess, yeah.
Okay.
It wasn't on the list of overlays right now, but we'll look into it. I don't think so.
So the answer for FY2024, Jay, is no. The BCOA will not be in those scenarios. The next question is, can the AC over AC work with a mill and fill option, thin up the original mix, and then add the overlay? And Voter responded to that. Milled thickness is a user-defined input for AC over AC design strategies, and that doesn't change for the multiple asphalt overlays. The next question is it possible to access the mechanistic responses? The structural responses are available when you select the general structural response in version 3. That's going to be a workspace setting. So if you go to your tenant management, you go to your workspace, your current workspace or your system workspace will have generate structural response, and you can set that to yes or no. And then Harold responded to that as well, and he is correct. There are only a limited number of pavement responses available to the designer user. It's been that way for a long time in the software. That's mainly just due to the sheer amount of data that gets computed as part of the responses, and moving that back and forth across the web application, that can be quite both time and cost expensive. So that's definitely something we've looked into in the past, making more of that data available, but no, it's not currently all available. The next question is the back calculation tool able to accept XLSX or CSV files? The BCT just imports the raw data formats from the FWD devices. We don't currently support importing the deflection data from SLXX or CSV directly. The next question is, does the web-based back calculation tool require a separate license? It does not. If you purchase Pavement ME Design, you have access to the back calculation tool. It's part of your subscription. You can purchase additional BCT licenses if you want to. Next question is how to access the back calculation tool web application. It's a great question. You can't yet because it's not done. It'll be done at the end of this month. July 1st, it's whenever our iteration ends. It might be July 4th. It's very early in July. We'll do a release that will have the web application back calculation tool. And you'll be able to get to that. There will be, let me go back to the slide here. There should be the very last one on here, yes. So you'll see this new icon in your Pavement ME Design, when you access the Pavement ME Design site. It's these 9 little squares. When you click on those, you'll have the option to switch between working in Pavement ME Design and working in the back calculation tool. So that's how you'll access it. the next question is, will the BCT imported data work with a local calibration in pavement ME design? Voter answered this one. So if the input files generated from the BCT are imported to the CAT, you can use those for local calibration. The next question is, can the BCT be used with TSD data? And if not,
Chad,
yeah.
Just for follow up on the previous one, I assume that was how I interpreted Jay's question, but I think the other one is if local calibration coefficients can be used when generating those BCT files. I think maybe it's from a workspace setting or something like that. I'm not sure if that's where it takes the information, or does it just use the global coefficients? But I don't know if that was the actual
I see what you're saying. Yeah, no. When it generates the DGPX file, it's just going to take the system defaults. There's currently no. That's a good question. There's currently no communication set up between the Pavement ME Design app and the BCT app with respect to the calibration coefficients. That's probably a good feature for us to add, Jay. So, yeah, that's definitely something we can look at adding. And as we mature the BCT web application, these are the types of features that we're going to continue to tighten the integration between the two systems. So, yeah, that's definitely something that we could look at adding. But no, right now it generates the whatever the system defaults are, and then you'll need to import from a library your calibration coefficients to that generated DGPX file. Hopefully I'm understanding Jay's question correctly. Next question is, can the BCT be used with TSD data? And if not, other plans to incorporate it? Voter answered that one. Looks like not at this time. The next question is, in the BCT, is there a plan to add a feature to back calculate layer thickness as well? Currently, only layer moduli can be back calculated. If we are not sure about the layer thickness, this could be a good feature. I would leave that question. We might need to come back to that question, Prajwal, and answer that separately. Probably have Harold answer that one. So I'll make a note to come back to that and get that answered for you. The next question is, does the web-based software, is that available for academic purposes? The answer is yes. That's been available this whole year, and it'll continue to be available in the future for educational use. So your educational license, or now subscription that you get for Pavement ME Design, that gives your agency access to the web application, and then whoever is in charge of your tenant, which is typically the primary end user designee, that person can invite via email within the app folks to join the tenant. So you just log in and then you invite your students. The next question is, when can we expect the in-depth technical documentation on the Julia refactor? Great question. That will be available at the end of June. That has to be made. I'm not sure what review process that needs to go through. So that's going to go to AASHTO first, and then the AASHTO will make a decision on what they're going to release. The next question is, how does the program calculate easels from the traffic data? Voter, would you care to answer that one?
Sure. I mean, it uses basically the same procedure as for how easels are calculated normally. The main difference is it assumes a load equivalency factor for your different bins, loading bins. Those values are hard-coded, and it doesn't really change. The help manual does go into a little bit more detail for that. I think that was a feature we added last year. But mostly it just calculates your total number of single or total number of axles based on your load equivalency factors. So I mean, there's not a big difference between how it was calculated before, or basically for FY2023 versus Pavement ME. But the analysis does not use easels directly. So I mean, that's what you need to remember, that it's going to use the actual load distribution data that's entered into the software. This is just to compare with agency values that have relied on easels. So it's a comparison.
Yeah, I'm glad you said that, and I'll reiterate it. The analysis does not use easels. That's just for comparison purposes. The next question is, how can Pavement ME Design version 3 be accessed? Great question. Voters answered it there below. You just go to the website. Typically what happens is you purchase your subscription from AASHTO. If you're an international organization, there's a slightly different process you go through, but either way, you end up purchasing the subscription. Once you purchase the subscription, you'll get an email from basically from the production server, and that email will have some instructions for how you set up and register your account. And then once your agency's account is set up as a tenant in the system, which again is just a few simple steps that are detailed in an email that gets sent to you, you can sign in and start using the application. If you have if you have an active subscription to Pavement ME Design and you want to access the web application and you're having any trouble with that, please send an email to pavementmedesign@ara.com or contact me directly, and I can step you through that process. The next question is, our local DOT hasn't moved past version 2.6. If we choose to use the web application, which is version 3, are there any known calibration coefficient differences that will affect the analysis? Voter has answered that question. I'll just read it here. There aren't significant differences between version 2.6 and version 3 for flexible pavements. For rigid pavements, the models were recalibrated after incorporating the NCHRP 151 model changes. So
and
for flexible, go ahead, Voter.
There too, we had multiple webinars last year on this, so that goes into more detail on the differences between version 2.6 and 3.0.
Yeah, that's an excellent reminder. Swing by the me-design.com website, and there's a webinars tab, and you can look at the webinars that were done on this topic. Next question is, can we expect at some point in the future a more comprehensive description of intermediate files, the variables, the units, more than what the current help manual provides? That's a good question. The answer right now is probably no. There's not a significant push to see what the intermediate files actually are, and in fact, the intermediate files, we wanted to do away with the intermediate files because they don't provide. We need to understand what value the intermediate files are providing to the designers. So one of the things that would help us move forward on a comprehensive description of intermediate file data is understanding which of the large set of intermediate files provide value to the designer and what information they need to get out of those intermediate files. The other side of that coin is, as we go through the refactoring process for the analysis modules, that's going to produce automatically much more descriptive intermediate file data. That was part of the problem with the technical debt that we discussed earlier, is that the intermediate file data is kind of well, as you said, it's a non-comprehensive description of the information coming out, at intermediate steps in the analysis. And so, as we refactor the analysis modules, sort of an automatic something that you just get as a part of that process is a more descriptive set of intermediate file data. So there's not a separate effort to do that, but some of what you're asking for is going to come as a result of the analysis module refactoring. The next question is, if the subscription for the web application version 3 also includes a standalone license. Which version is the standalone version? It's a great question. Make sure I understand this correctly. If you purchase the subscription for FY2024, or if you get the desktop application, both of those things give you access to the web application. That was a decision that AASHTO had made in order to help the DOTs transition from previous versions of the application to the web application. So if you purchase a license for the desktop application, you will also get access to the web application, same number of seats that you purchased for the desktop apps. If you purchase one license, you'll get one concurrent use license seat in the web application. Hopefully that answers that question. Harold has an answer to the layer thicknesses question, so I'll go ahead and read that. Layer thickness cannot be back calculated with the BCT. Harold is assuming this refers to using the time series deflection data. And time series deflection data is not used by the BCT, and there are no plans to determine the layer thickness from the BCT. The layer thicknesses need to be determined from the GPR data prior to using the BCT. Also, he does not believe there's a standardized tool for back calculating layer thickness similar to the back calculation of elastic layer modulus tools. The next question is, can an agency have multiple versions of the software at the same time? So the example that was given is version 2.6 and version 3. The answer, that's a little bit of a tricky question because the version 2.6 is the desktop application. If you purchase any license of the desktop application, you get access to the web application. And again, that's to help folks, that's to help the DOTs make the transition to the web application, because we know that's not just flipping a switch. So they need to have access to both. So the answer is yes. If you buy a license for the desktop application, you will have access to the web application with an equivalent number of license seats to concurrent seats in the web app. The next question is, can you please explain LTE inputs for flexible pavements as part of rehab design? I'm guessing we're going to need to come back to that one with a longer answer.
Yes.
Okay.
So and with the next webinar too, I think there'll be an additional explanation of the LTE of those existing pavements.
That's for multiple overlays, or is that?
It applies to both, both the first overlay and multiple overlays, but it really affects how quickly any existing distress propagates through the overlay layers for reflection cracking. I mean, that's where LTE is used for rehab.
So Sam, we'll get back to you with a memo on that question. And then Harold is just expanding on his answer above. The GPR data can be used to determine the layer thicknesses, but that needs to be done external. That's done external to the BCT. With respect to the intermediate file question, we've discussed this with the task force. The decision was to provide the critical pavement responses and identify those more specifically so they can be used if needed. But there's still a limited number of critical responses, so it's exactly what we discussed earlier. The next question is, when will the stabilized base selections be available for use? I'm not sure I understand that question.
Yeah, it might be the stabilized base layer type, which is kind of combined with the cement base, which includes both, which is your stabilized base materials. It's not, I think that's what they're referring to, because the stabilized base specific items are like how some of the layers were characterized, but for the most part, like cement base includes your cement stabilized, lime stabilized layers, and I think that includes, that's supposed to represent your stabilized.
Those are already available.
Yes.
So yeah,
I don't really know 100%.
Next question is, can an agency user access the web version of the software from anywhere using any capable computer? Yes. The only requirements are you have to have either the Chrome or Edge browser. I mean, technically you could do it with Safari, but, well, some of the features won't work. We're using a file access API, so it's got to be Chrome or Edge. Conceptual questions. Okay, so for conceptual questions, is the correct channel the help desk? Yes. Please send conceptual questions to the help desk. We have a system in place to handle those customer support tickets. So we'll generate a support ticket and we will get a response back to you. Harold's responding to the LTE question. This is covered in the manual of practice. The LTE can be measured in the field for transverse cracks, but for alligator cracks, LTE is more of a calibration variable for reflection alligator cracks. The next question is, will a chip seal be added to the maintenance activities, and can multiple chip seals be added to the program? Greg, we'll have to write up probably a separate response to that. It's not currently planned to add chip seal to the maintenance activities. So we'll need to discuss that further, I think. But certainly, I'm assuming that's something that could be added. The next question is, how does BCT address temperature dependency in the AC layer? I see when the BCT data is imported to PMED, a reference temperature of 77 degrees is assumed, but what if the pavement is 90 degrees during testing? I will let either Harold or Voter answer this one.
Yeah, so from the back calculation tool, if you have pavement temperature included in your FWD file, then it can take into account the actual temperatures. And then I think you can actually specify a reference temperature as well.
That's correct.
And I know there's additional features coming in for predicting pavement temperatures if you don't have a value.
Okay, hopefully that answers the question. The next question is, are there any updates to the academic license? The university's computers are mostly managed by centralized servers, and they need to activate the software each time they work on the software. So there's no updates to the license, but I would recommend that the university just move to the web application. Then there's no installation on any machine anywhere. You just access the software as a service. The next question is, will the user be able to access multiple versions in the web-based interface? For example, version 3 and then version 4 in the future. The answer to that is yes. We're going to stand up multiple instances of different versions of the application in order to allow agencies time to switch from one version to another version and to give time for folks to do the necessary calibration work. And so you will be able to access that. There's kind of a couple of different ways that that's going to work. One, when you upload a design, the design will automatically, basically it knows what version it is, and so it'll automatically take you to the right place. Or you can manually navigate to a specific version within the UI and generate designs in that version of the application. Harold has a comment. Chip seals are part of the maintenance activities or strategies for flexible pavements, but only one maintenance strategy is used. Next question is, if an agency needs to make a large number of runs for local calibration purposes, do they need to purchase additional server time? Or does having a valid license allow them to make as many runs as they need to? That's a great question. So there are two different answers here. One is, if you're going to be doing, let's say, calibration runs, I recommend using the calibration assistance tool to do that. The server that runs the analysis for the CAT is specifically set up as a compute instance, so it will be much faster to use that server. So that's A, you use the CAT for calibration. If you do have a lot of runs, say for sensitivity or something, the server is going to queue up your runs. So right now the server, we have one production server, and it can run up to 5 designs at a time. Typical design, 25-year design life takes about a little over 2 minutes to run. We've set up a fair queue in the system so that there are no blocking operations. Nobody could queue up 1,000 designs and then other people can't, get their designs run until those finish. That's not the way that works. The system is going to look at the analyses in the queue, if there are any, and it's going to pick the one from the next tenant and sort of interleave all of the tenants that way together that have queued up designs. So if somebody does run a substantial number of designs, the system's going to ensure that that's not blocking people from, running 1 or 2 designs, for example. Additionally, you only have 10 gigabytes of space per tenant available to you on the Pavement ME Design production server. So if you run, each design is about somewhere between 15 and 20 megabytes. So if you run many of those, you're going to quickly run into your limit. And then the server won't allow you to submit more designs until you have deleted some. Periodically, every 5 days, the server goes through and automatically deletes completed designs. Once your design has finished running, you need to download the results because the server is going to clear that off. Because we don't manage any user data. That's all up to you all to do that. So the answer is you can run as many runs as you want, up to certain data transfer and physical memory limits that have been set on the production server. The CAT, you can run as many as you want. I think you can run up to 60 hours of data per calibration run in the CAT, but I need to double check with Ian Ben on that. Then that has far less, let's call it permanent data storage requirements, and so we don't have any of those types of constraints built into the system. So hopefully that answered your question, Will. We had another question pop up. There is a limit of 1,000 sections in the CAT, and you cannot delete sections once you upload it. This will make the CAT not useful after a certain point in time. Will we be able to delete sections in the CAT in future updates? If I'm not mistaken, you can archive runs in the CAT, and I don't know if that allows you to. I'll have to follow up with you and Yenbin on this one, Rahul, to understand what the exact constraints are. But I think you can archive designs. Looks like Yenbin might be answering your question here. So we'll wait for Yenbin to finish there. And then another question, any change in top-down or longitudinal cracking model in version 3, I'm assuming? And the answer is no, I don't believe there is.
I mean, the top-down cracking for asphalt pavement changed back in version 2.6.
Correct.
Yeah, so no changes since then.
Yeah, no changes since we implemented the new top-down cracking model in version 2.6. Okay, I'll give it another minute here. We do have plenty of, we still have plenty of time, so I'm happy to answer any other questions that come up. I don't want to cut anyone off, so if you do have questions, please type them into the box. Be happy to answer. And Rahul, we should have an answer for you here shortly. We had a question, somebody wanted to have access to the new design manual for the web application. If they're talking about really either the help manual or the manual of practice, those are both available directly in the web application. There's a little question mark icon on the top right of the web application. You can just click on that, and it'll provide you access to the either the help manual or the manual of practice, the most up-to-date one. So Yanbin, in answering this question about the limit of CAT sections, uploaded projects may have been used in previous calibration projects, and so deleting them makes the exiting calibration project sort of obsolete. So we could implement something so that if you upload a DGPX file that's not used in any calibration projects, that can be deleted. So Rahul, I think we need to probably have a separate conversation, you know, because I agree that this is an issue. We just need to figure out, you know, how to address that for the users. So if you could send an email to me, we can sit down with the Yanbin and have a longer discussion about that. Okay, another question. Are there any upcoming webinars planned for local calibration purposes, utilizing the CAT, utilizing the latest version of the software? I don't think, I'll let Harold and Voter answer, but I don't think that there are. And I think that there's going to be there's definitely going to be training at the user group meeting.
Well, I think for FY24 as well, I mean, we're looking at updating the local calibration guide, the AASHTO published document.
Yep.
And I think from that, there will be additional webinars regarding the local calibration procedures and focusing on the CAT, and then also transitioning from different versions and what to look for. But that guidance will be in the updates to the local calibration guide. As Harold just kind of put, Harold put his answer here as well.
Okay, the next question is, the default calibration and bottom-up fatigue cracking has changed a lot with version 3. 100% of AC damage does not correspond to 50% of FC anymore for the average 50% reliability level. It was a key conceptual feature of the original MEPDG. What happened? So I'll let Harold and Voter respond to that.
Most of the calibration coefficient didn't change in version 3. It changed back in version 2.5, where the mixed coefficients and the field shift factors were adjusted, separated out. But I know Harold will probably have more information on that. And it was also found that there was a bias between different thickness values. So that's why the bottom-up fatigue cracking coefficients, both the C field shift factors for the transfer function plus the damage functions were adjusted to be based on the thickness of the asphalt layers.
Thanks, Voter. If you need more information, be happy to provide that. Just send an email to the help desk, and we'll get that routed over to the research team for an answer. Yeah, and Harold can't unmute himself, but he'll answer that question in more detail in the webinar report, and then we'll make that available for download from the ME Design website. So while we're waiting for any last questions to come in, I do want to encourage everyone to attend the PMED user group meeting in September in Madison, Wisconsin. There's a link here to register for that event. Really looking forward to that meeting and to seeing everyone again and answering questions about the software and showing the new features that we're implementing in FY24. So when you get a chance, hop on the website and register for that. Looks like we don't have any other questions. So with that, I'm going to hand it over to Clark to wrap up.
Okay, thank you very much for a very interesting webinar, Chad. I have some contact and resource information that I want to make sure everyone knows is available to them. For issues with AASHTOWare Pavement ME design, you can contact the AASHTOWare project manager, Ryan Fragapane, and you can see his email address and phone number on the screen now. Or you can also contact me as the task force chair, and my email address is given there as well, cmorrison@ncdot.gov. I'd also like to point out our ME Design Resource website. That's me-design.com, and there's a lot of information available there. Our previous recorded webinars are available at this site. As we mentioned, the user group meeting is coming up soon, and the management of our user group has changed from the pooled fund program to being managed directly by AASHTOWare now. So questions on that can go to Ryan Fragapane, our AASHTOWare project manager, and again, his contact information is there also. If you have questions about the operation of your version of the software, those can go to the help desk and customer support office. Probably the best way to contact that is through an email to pavementmedesign@ara.com, or there's a phone number to access the help desk as well, 217-356-4500. Other ARA staff who support the PMED program include Chad, Vooter, and Harold. Their contact information, their contact email addresses are there. And again, another access point, or the same access point, is the help desk phone number 217-356-4500. And I'd also like to thank all of our attendees for their time in attending the webinar. And we'll bring this to a close now. Thanks to everyone.